I don't. You don't need to mention it. All right, good morning, everyone. We have, I think it's company number 5. Six. SurvTech and SurvTech Solution. Second time you've been here. The first time we actually was impressed by you all and what we have, what quality for students working you all. We have Carlos here. He's also looking at. There's a little surprise later on. You will see him again in the future. But he's here to talk to you about the types of work that they do, the technology that they are involved in, more importantly, about the job opportunities for students who are about to graduate and also co-op opportunities that are interested. Thank you for the tour with you. See if you can share it around, but thank you very much. Appreciate it very much.
Thank you, guys. Thank you, ladies and gentlemen. Yeah, I'm glad to see some diversity here. This is a career that for a year has been just kind of exclusive to man. I don't understand why. So I'm happy to see that joining on. My name is Carlos Prieto. You can just call me Carlos, and I'm here representing SurvTech. SurvTech is based out of Tampa, Florida, and we are what we would call a complete geospatial. Now, before I go any further, let me just ask Ron. You guys are all in your 20s, but yeah, boy. I am. Okay, well, yeah, there's a few outliers there, but that's okay. What I would give to go back, you are in such a special place here because I was just talking to Dr. This program here is kind of like a hidden gem. The exposure and the preparation that you guys go through from your head. Not very well. I like to see it, better known out there. So we're just happy to be, helping in any way here, participating in this program. You guys are going to be the future of geomatics and surveying and GIS. Are most of you geomatics here surveying? Okay. Any GIS? Fine. So in GIS, if you have the ability to not only dominate the themes and dominate the software, but if you can do coding and custom applications and that, it's good for your software. Think about it. You are the future now. You're going to be the leader. And it doesn't matter where you are in the program or in your life, somebody is looking at you as the leader. So, think about it. So back to SurvTech. We started as a survey company, just purely survey, but founded by 2 surveyors in Tampa, Florida. And this is back in 2007. So you're 20 years old now. And over the years, we have evolved into a full geospatial, adding different technologies. And here's a few minutes on the we basically map everything that there is to map. Do it land, from the air, underwater, underground. Land, we do traditional survey work, boundary, route surveys, you name it. On land, we also do a lot of indoor scanning, static scanning from Prieto, from wearable scanners. All of that data, ends up being used in some sort of the digital twin. That's kind of a catchphrase now. All of that data is now being, going from the air. We have a different number of platforms, fixed wing aircraft, helicopters, a lot of drones, and all the technology that comes along with it. LiDAR scanning, imaging, RGB imaging, multispectral, some thermal imaging, and then underwater, we do a lot of acoustic bathymetry, single beam, multi beam, side scanning, and all that. And then on the ground utility surveys, we use ground penetrating radar and a number of different technologies that you guys are familiar with. We are about 100 people right now. We've kind of been hovering around that in the last 3 or 4 years. We have we're headquartered in Tampa. We have a handful of offices, around Tampa. We have a small presence in San Juan, Puerto Rico. We have a production center in Decatur, Alabama, just right outside Huntsville. I'm the one-man show in Mobile, and then we have an office in Louisiana, and soon to open an office in Houston, Texas. The darker states that here, these are the states that we have survey licenses, professional survey. So as you can see, we're pretty strong in the Southeast. We have Colorado and Maine, and also Puerto Rico. The president and one of the founders, David O'Brien, he is licensed in, I think it's 11 states. But in total, we have 13 states and Puerto Rico. He's also a certified federal surveyor. We have 9 professional surveyor mappers in Florida. Florida, they're called PSMs. And a lot of these guys have kind of grown through survey. So, we have a very good, pretensions. We have certified programmers and geologists and full-time safety. So on the land, we still perform all the traditional tasks of surveying mapping, from boundaries, as-built design routes, float stations, GPS, chronic levels, and so on. We do our own drafting. We don't have like an overseas partner and that's work in-house. We also have a metrology, and if you're not aware of metrology is the ability to measure with a much higher accuracy than traditional surveys. With metrology, you can measure baselines within 10,000 of them. And the instruments that are used for that, they're called trackers, and they're kind of like float station and steroids. That technology is used for bridge alignments, for we've done a lot of work in the space industry and the Blue Origins and some others, where you need this type of, the tolerances are very, very small. When you're aligning rockets, when you're aligning bolts, and that type of. Inland land is a lot of terrestrial and mobile LiDAR. We also use the SLAM LiDAR. SLAM, is the new algorithm that it's used in environments where you don't have GPS. So it's a very proven technology. It kind of checks in itself, as you travel scanning. So we have sensors that we can put. You can see on the far right, sensors we can put on a truck or a boat or an ATV. We're doing all sorts of different type of scanning, LiDAR scanning. We can add 360-degree cameras. So it gives you kind of like the Google, street view type of process. Terrestrial scanning with 5-foot mount scanners. I think we used Leica what is it, 360 or something like that. We have a couple of older aging Pharaohs. And then on the SLAM technology, we have push cart. That's a little bit bulky, but it does the job. We tend to favor the like to call it backpack. It's like a shoulder mount, type of scanner, where you're scanning along the way. You're taking, collecting all this lighter point density and also taking images, and they're correlated with each other. A lot of that is done for BIM models or digital twins. One of the cases where we used scanning and we used metrology, this particular facility in one of the theme parks in Florida was designed and it was going to hold one of those. It's like a canvas type of roof. So this is the frame that was going to hold that. They designed it, they built it, they shipped it to the site, they started assembling it, and then they discovered that it didn't close. I think you see right there, there was a disclosure in the structure. So we were hired to scan the structure and then compare it to the design, the actual design, and see where things were from. And in fact, they have put together, they have assembled a couple of different pieces the wrong way, and then ended up close. Kind of an expensive mistake. Another scanning example. This is a lighthouse in Florida, and got hit by I think it's Hurricane Ian. Went through there, and there was a pier that had suffered some structural damage. So we put a static scanner on the outside, and then the wearable scanner inside. There's a staircase, a spiral staircase inside. So we were able to scan it all, put it into the model, and in fact, we discovered that I think that this member here, you can see it's got a little bit of a bend in, and it shifted the center of the entire structure. It shifted. So with that type of evidence, they could make a plan for the corrective actions for the structural damage. All that scanning also, we could build it into 3D models, again, BIM, CAD, Revit, a number of different outputs. It can be done from the outside. A lot of times we combine technologies together. We may fly a drone with LiDAR for the outside, and then we do maybe some scanning, wearable scanners inside, static scanners on the outside. We could put it all together using common ground control points. That's the key to make everything. From the air, we have a fixed wing platform, and it's twin engine Cessna aircraft. We have a Teledyne Optech LiDAR sensor. This is T2001, the latest generations. What's unique about this sensor is that if you see here on the top, areas where there's a lot of relief, the swath of data may change just because the altitude from the airplane to the ground is changing. So this sensor has an adjustable field of view where it adjusts and collects more data or less data depending on the relief, and you end up with a more even distributed point cloud. And so that's a lot of times that's desirable, especially if you're doing large area collections. And we do participate in some of the national elevation programs. It has a national elevation program where we tend to fly the entire country the goal is every 5 to 8 years. It doesn't always happen, Uh, the east side of the country is obviously more populated, so there's more demand for it. And then if you live in Montana or Wyoming out there, then, I mean, you get it once every 20 years. Um, so this setup also carries an RGB camera, so you collect elevation data and imaging at the same time. And again, is designed for large area mapping, but it does very well in corridor for smaller areas. The same type of technology, LiDAR and imaging, we have it available on the helicopter pod. This sensor carries a Regal LiDAR sensor for your elevation data, and then 3 additional cameras. One camera is looking straight down. That's your nadir camera that gives you nadir perspective. You can do aerial triangulation, orthography, feature extraction out of that. And then it has 2 additional oblique cameras. One's looking forward, one is looking back. And it's designed with utility corridors in mind. So if you're flying a utility corridor, you're collecting LiDAR data of all the infrastructure, vegetation, ground, wires, and on the same path, you're collecting all this imagery. And forward and back obliques gives you a different angle of the structures, power poles, towers, and so forth. The data that is captured out of this, you're flying 600 feet, 600 to 800 feet from the ground. You're flying 50, 60 miles an hour, so it's relatively close to the ground, and you're collecting a lot of data. So you can actually see individual wires, you can see the ground, you can see vegetation, you can see power, the poles. You can even see the connecting points between wire and poles. And all of this can be classified, put into different layers, and typed into a PLS CAD model. PLS CAD is a fairly traditional output for utility data set. You collect all the vegetation. You can do vegetation management on utility corridors, which is pretty important. We're about to see what's going to happen. Definitely, we have a hurricane coming in here. Utility, companies are racing, against time, to clear their corridors. And with this type of collection and this type of data, you can run different scenarios. How close the vegetation is from the lines, and then you can flag that and send your crews, to trim the vegetation where it's much needed. Again, you're collecting LiDAR point cloud, and you're also collecting imagery. You see the 3 views here, the nadir in the center, and then forward, left, and aft or back view in the back. And as you can see, there's a lot of detail that can be captured. You can see, I think there's a number 3 on those poles, so you can see a lot of identifiers. I mean, it amazes me the type of detail that you can capture. Well, you're still going 50, 60 miles an hour. The same technology now available in UAVs. I know you guys are very familiar with with that type of platforms. We have a number of them. The ones you see here, the coppers that you see on the right side, these are American-made drones. They call them heavy lift drones. So they're able to handle a little bit heavier payload. We use them for LiDAR sensors, some of them for imaging. This one here on the bottom right, what's unique about that's a hybrid drone. So it's electric, and it also has a 2-stroke engine. And that allows you to have, added endurance in the air. instead of going up and down every, 10, 15 minutes, you can stay up in the air for anywhere from 60 to 80 minutes, depending on the payload that you're carrying. So it allows you to do larger areas, and every time you get up and collect the data set, the larger the data set, the better it will be. Instead of doing, little pieces here and there, you then have to kind of calibrate it and put it all together. Having a larger data set, that's a benefit. I'm sure you're familiar with the WinCrawl 1. That's a imaging vertical takeoff drone. If you were here last year, you may have seen it fly, and it takes off vertically, levels off. You pretty much don't fly drones anymore. They kind of fly, from their own. You do have to, prepare a mission. You have to, design a mission, put a fence around the area that you want to fly and so forth, and then you kind of does the job. And when it's done, it comes back and it lands in its tail. And this drone stays so busy for us that we recently purchased a second. You can put a couple of different payloads on it. They just came out with a LiDAR unit that you can put on that one. We haven't tested it yet, but an array of different cameras, RGB cameras, multispectral, thermal cameras. So very, very versatile. It's been a workhorse for us. And I wanted to showcase the benefits of having the two data sets together. Imaging is pretty powerful. You can do a lot of analysis, you can do mapping, you can do workflow imagery out of that. But then having the elevation data, behind it, you put them both together, it just makes for a much powerful and compelling final product. The resolution of this images are pretty impressive. This one at 400 feet AGL above ground, which is kind of the seating for drone flights at this point. And so, the background is it's a rectified mosaic, and it's got several images stitched together there. But you can see the amount of detail. I mean, you can even read some of the writing there from on the ground. So we use this pretty frequently. You can do, digitizing, you can do feature extraction out of that. Very, very, very good technology. Underwater, we have a number of different boats, different sensors. To survey below the water, it's typically use some kind of acoustic device, so commonly known as sonar. And sonar can be in the form of a single beam. That's a single team thing, as it travels along. Multi-beam is kind of like a fan of data. You're scanning there. It behaves a lot like LiDAR in a way. And then you can put, all sorts of different sensors, size scanning, magnetometry, subbond profiling. We own all of these sensors. We like to own our equipment and our sensors. The only thing we don't own the airplane and the helicopter. We don't want to be in the aviation business, so we have a provider, that it's pretty much exclusive to us. This boat here is one of our most popular boats. This is it's kind of like a wave runner with pontoons, and it's a single man boat, but it's got a very shallow draft, so it's very maneuverable. You can put different sensors on it, any of those listed there, and additionally, from this one, on the top of this mast, we have a LiDAR sensor. So when you're doing coastal surveys, you can survey the upland, structures, wharves, piers, and so forth, above the water line, and then below the water, obviously, you're using the acoustic technology. to survey.
How many of those boats do you have?
We have about 5 boats. So this is the smallest one. We have a couple of skiffs. That's our newest boat. That's a 20-foot. We have a 25-foot boat also. We don't do any deep water work, but we do a lot of coastal, inland waterways. We do a lot of ponds and lakes. Yes.
Is this to put in like piers, or is there any specific example that you're for depth? What are these services?
This image up here, this is Tampa Bay.
Okay.
And that's a navigable area. So we are on a contract with the port. In case there's a hurricane or something like that, we're there the next day, when it's safe to go back in the water and make sure there's no debris or no obstructions that may impede navigation.
That's when you'll be there on
Yes,
Saturday.
yes. So, yes, I want to be there and I don't really want to be there, but if you don't want to be there. Another application is we do a lot of work for the mining industry in Florida. There's a lot of, in Florida, they have this, what I call open pit mine. So they dig big hole in the ground and they take sand or, some other material, and then it fills up with water. And they want to know what the volume is and what the volume of that liquid is. So we do a lot of, these type of surveys, calculate volumes and deliver them. So am I doing something wrong here? Yeah. I'll keep going. Keep going. We also have remote control boats be able to do the same work. And the reason why we have these is because there may be bodies of water where it may be difficult to get in and out. You may not have a boat ramp, or it may be a contaminated pond or acidic pond. We do a lot of surveys on acidic ponds. So environments where you don't necessarily want to put people in, you can do it, with this remote control. The one on the left is our newest boat. This one is a Teledyne single beam, and the one in the middle, we just recently retired that. We actually built that boat ourselves about 10 years ago. This technology was very expensive then, and we figure, well, what if we can build our own? So that's really a kid's kayak from Walmart.
Yeah.
And we put a lot of, all this expensive equipment on it, but it turned out to be very, worked very well. Underground utilities and shit like these things. And you guys are aware of a lot of these technologies, but we do levels A through D. And D is the less expensive level. Level B, you just basically do some kind of research. Are there any buried utilities there? You look for evidence. Then level C is it's more intrusive. Level B, you're using other equipment, and then level A is actual location of the utilities. And to locate them, you have to know where they are. You use ground penetrating radar or ERI, all these technologies, looking for evidence for okay, where something may be down here, but unless you dig, you just simply don't know. So we have all this equipment to be able to do that. Unless with vacuum excavation, or you can do air excavation or water jets. there's a couple of different technologies depending on the environment. Some of these utility corridors can be very, very busy, and there's no technology unless you dig. There is no technology that will, tell you or show you exactly what's in there. And what's happening is that early on, we were digging really deep for our utilities. Okay, and then later on we started digging, just very shallow. So we had utilities deep, very deep, and then some very shallow. And now, we're putting utilities even in between because, it's kind of running out of room. And in reality, a lot of the larger cities, it's a big problem because you don't know where all utilities are, and that, it's a lot of speculation. Concentrating radar is, it sounds really cool, but it really needs a lot of interpretation. And you may have seen some of that. But up on the, on the upper left, that's really what the operator is seeing. It's seeing that there's a disturbance in the field. Okay? Or there's a disturbance in force, but that one. For the stuff. Anyway, so you're looking for evidence that there may be something there, and it may be a rock, it may be a pipe, it may be a log. You just simply don't know. So you do those kind of markings, and eventually, with some sort of excavation, vacuum excavation, further, you'll be able to determine, what's in there. Point clouds, we have been dealing with point clouds for a long, long time. We have folks that have worked with LiDAR since the late 90s, when the first commercially available LiDAR units came out of the market. And it didn't collect a lot of points. We had a huge learning curve, what to do with all this data, how to interpret it. So we're very familiar with the evolution of LiDAR point clouds. The sensors now are so much more efficient. They collect a lot of data, a lot of points, and even in vegetated areas. And this picture doesn't really do it justice, but if you see that there is kind of a defined line here where the ground would be. So there will different classification methods, classification routines, a lot of it automated, and some of it just manual. You can classify vegetation, you can classify structures, you can strip that out, and you'll be able to show what we call the bear curve, so it's still a rapidly emerging technology. AI is playing a big role now to be able to determine what is ground, what is a car, what is vegetation. So we're going to see big advances in the next 10 years. This is a utility corridor. Again, LiDAR and imaging. You can see individual wires, you can see poles, you can see vegetation. This happened to be done with a UAV and a LiDAR unit on it, but it could have been done with a helicopter or an airplane. We happen to have all these options as a company, and so we're fortunate that we have all this at our disposal. So small area, we may say, yeah, I think we can put a drone there. It's a larger area. Well, you don't want to have be surveying there for days, and you can put a helicopter, or if it's in a larger area, you can put a fixed wing airplane. And in some cases, much more efficient. Again, the ability to classify LiDAR data. You see on the bottom, the image layer, a lot of trees. There's a building there on the upper left. The bridge decks, all of that can be classified, can be removed to get to a topographic representation of the ground. This is the type of work that, you know, without LiDAR, I mean, would have taken days or weeks, you know, with boots on the ground. So this is really an exciting time to be in this type of technology. Because there's just so many options now that we just simply didn't have. And then up on the top, you can see we put a cross section there. You know, you can see how the terrain is changing. We do a lot of volume calculations from aerial imaging or LiDAR. We tend to favor LiDAR data just because it's a little bit more accurate. It's more loyal to the features, and you know, if you have vegetation on the edges, chances are you're going to have some penetration and better chances of being able to reach you know but you know, through different software routines, you can outline areas of interest, you can build surfaces, and then you know, output you know, volume calculations. This is from a recent flight up in North Carolina. This was done for the Corps of Engineers. This is a fixed wing airplane with a LiDAR and an image at the same time. What you see here is the final rectified imagery. This is just a portion of the mosaic. So there's several frames stitched together. And it's, you know, it's a very valuable layer. You can see the vegetation, you can see features, you can see roads, you can see the levees, you can do a lot of feature extraction. But we flew LiDAR at the same time, and the LiDAR was able to penetrate, you know, the foliage so effectively that it revealed, you know, all this stuff that it was basically hidden, you know. So this type of technology now is by far the most effective way to survey, you know, larger sites. I'm going to say, you know, different sizes. I mean, this is the kind of stuff that we just didn't have, you know, 20 years ago. So it's a compelling, powerful data set, you know, to be able to have both of them. This is another project that we did in Florida. This is a jetty, and we were able to put a multi-beam boat on the water. So you can see some of the erosion. They wanted to see what the status of an assessment of the jetty. You know, they need maintenance. You know, they need more rocks or less rocks. You know, is it doing the job? So multi-beam on the water. Then we put a terrestrial scanner up on top, and they wanted to be able to see each individual rock. So the static scanner, you know, puts out a very high density of points, and you know, you will pick up individual rocks. All of this, you know, we put it into a single elevation model. We use common ground control points for both data sets, make sure everything fits. This is another jetty with just a larger area. And again, I mean, you can see some of the erosion that's caused by, you know, moving water. We flew our aircraft in this case because the client wanted us to use the drone. But there's a naval base there on the lower right, and I mean, it would have been very difficult to get permission to fly. So we had the options, we had the technology. We decided to put a plane up in the air. We collected imagery and LiDAR, put a boat in the water with multi-beam. We also did side scanning. And the side scanning and the multi-beam revealed a couple of different things that I'll show you in a minute. But we were able to put all the data together. We designed a control network. They wanted us to tie into existing control. There's NGS control in the area. There's also Corps of Engineers control. So we visited all of that, designed a control network, added photo identifiable features to be able to control the photography and do photogrammetry as well. Just to give you a flavor of how powerful some of these technologies. See the image layer on the left, and then bleeding into the resulting multi-beam surface from the sonar. This is not a picture. This is a intensity image of the LiDAR points collected. There's so many LiDAR points there, and LiDAR points not only have elevation data, but they have what's called intensity, and that's just a reflection of how reflective the surface is, and it ends up looking like a picture. You see the LiDAR here in black and white, and you see the multi-beam surface in color in the back. This is the actual jetty, and the color data set is the multi-beam, and we found a couple of different sunken boats right next to the jetty. They're not visible. I mean, they're below the waterline. Let's see. Yeah, there's two of them right there. There's one over here, and there's one over. I mean, it's not a small boat. There's like 100-foot, boat there. It's old metal. I mean, it wasn't we didn't find any gold or anything. It was kind of a newer boat, but it's, it was there. It happened to be in the outside of the jetty, so it's not really impeding navigation. But nevertheless, we let the Corps of Engineers know, so they can take appropriate action on navigational charts. Now, we also had to do beach profiles. This is boots on the ground, and not everything goes well. Okay, and I want to show. So we sent a crew there, and this beach profiles start in the land and then go, 1,000 feet or so in the water. So we put a boat in the water with a single beam. Okay, so they take measurements, and then we put a crew on the beach, and at some point they had to come together. Well, they did. So we had to go through the data and show them, okay, these are the gaps that we're finding. Send them back. What happened here? Was it too shallow for the boat? Was it too rough for the crew? It could be a number of different things. But some of the data set just didn't fit. I mean, you can see, and the boat, may have been fighting with currents and waves and all that. You can see, I mean, that's just real data, as it was collected. A lot of, smaller gaps. There was one where, there was an 80-foot overlap. Well, overlap is fine. I can deal with that. But, are we not using the same alignment? I mean, are we not communicating? That's the type of thing that when you're dealing with the real world out there, you have to work. There's another gap there. So, it took several iterations to figure out, what was it. I'm coming to an end here. We do a lot of data fusion. We happen to have a lot of technology, a lot of sensors. We combine them together to solve different challenges, and depending on the scope of work of the project. This particular roadway, this is an aging bridge. They wanted to survey for, a mobile mapper, mobile lidar on, through, driving through the bridge, UAV lidar, UAV, imaging, from the top, and then multi-beam boat, to be able to, survey it all together. Again, use common references, common reference points, make sure the data fits together. And these are one of the many reasons why our clients, hire us, because we don't have to go get a hydro company, or we don't have to go get a survey company, or, make a team like that. We can handle all this. We also do a lot of GIS work. And that means we can deliver, GIS compliant products, but we also do a lot of coding and enterprise GIS solutions. We're having to hire more and more people that may have experience with coding on GIS environments in the cloud. So if that's an interest, that's a good field to be. How all this data is used. I mean, nowadays, everything is geographically related. Okay? The phone that you use knows where you are at all times. We're going to have self-driving cars, and we got to know with all this structure, all this, buildings and roads, and we better know where they are, with a lot of accuracy. I mean, if I'm going to get in a car that's going to drive me, I mean, we're not quite there yet, but it's coming. But it's an array of different uses for our technology. And, just to kind of give you a snapshot of some of the equipment that we have. Surveying is not a lonely, career. I mean, you can make a lot of friends. You can go travel the world. So, I'd like to open it up for questions if you have any. I'm not an expert, but I'll do my best. Yes, sir.
Do you have any openings for like December for co-op opportunities during that time?
Yeah, so I'll put you in touch with our HR group, and if we do have opportunities, I know we're a little bit out of the way because headquarters. A lot of this happens in Central Florida. We do have a production center in Decatur, and typically it's a paid position, but we don't pay for housing and transportation. So, yeah, I'll leave my information here, and I can get you in touch with HR if you're interested in that. And what we typically do when we have interns is that we may design a time where you can spend time on different departments or different technology, and that kind of gives you a flavor of I mean, it's not perfect. It doesn't always happen because we're dealing with real deadlines and real work and so forth. But we welcome that.
How many are you looking for in terms of co-op opportunities and senior students about to graduate?
It all depends on our schedule. But 2 or 3 of them. I mean, I think that's feasible. Definitely like to be in touch. Yes.
Your Mobile office, do you have any idea what they offer there?
In Mobile, it's just myself, and I do a lot of project management. My background is in photogrammetry.
Okay.
And so I handle a lot of the image processing, image classification, mission planning. That's next time I come, I think that would be important thing to show you, how things come together. A lot of us that come here and talk to you guys, show you the final product. So I think it'll be interesting to basically dissect the projects from the scope of work, and then how do we get to the planning? How do we get to the execution? How do we, what problems do we have? How do we get to the final? That'll be. Anybody else?
What's the pay normally start at for
But that,
graduates? What's the pay start at for graduates?
I don't know. But I'll be happy to find out.
Employment package,
Yeah, if it's, I mean, if it's full-time, yeah, you'll have, yeah. And again, I'll make sure that our HR, person can help on all that. Look, I'll leave you with this. You guys, you're gonna be leaders in the industry. You're gonna be facing challenges and different problems. And how do you solve that? How do you the process is just as important as the technology. Okay. Just because we have GPS now doesn't mean that all the points that we take are good. Okay. So, be aware of the process. And in finding solutions, when you define a problem, when you define a challenge, okay, in any difficult situation, when you define what the problem is, that becomes 50% of your solution. Let's say you're driving down the road on a car and then the engine quits. Okay. You pull over, you don't come out of the car and go change the tire and come back and try, you try to assess, okay, what is the problem? Well, it's not overheating. I mean, all the tires are good. The oil pressure is good. Oh, the fuel gauge. Okay. So I don't have any fuel. Okay. So I just defined the problem and I have 50% of the solution. Why? Because now I know I have to get fuel. Okay. So, in any given challenge, just try to work it out that way. What is the problem? The boundary survey, the corner missing, corner disturbed, is my equipment working? I mean, just kind of work it out. You guys are in a very blessed position here, have all this knowledge being poured into you. And then I'm looking forward to see you guys up there. And then as leaders.
Would you be interested in some of our GIS majors? Because we have students who do GIS majors, but they know about it minor.
Yeah, I think that's a desirable training because the type of GIS development that we do is mostly development. Having that understanding of geomatics, having that, or even right now we're lacking on GIS programmers that may have knowledge on utility. Utility network, or what are the utilities company wanting? There's a lot of utility packages that go along their GIS and GIS. All of these GIS packages. That's a rapidly growing. There's a mandate right now from the federal government to map a lot of the area of utilities, facing resiliency and storms and all of this.
How many licensed surveyors do you have?
We have 13. Yeah, we have 13. And we encourage, David O'Brien has 11 states. So it's a challenge. It's a challenge. He said evidently he does very well taking tests. He just got Arkansas last year. But we're encouraging our younger surveyors, to take on other. We have 9 in Florida, and We have, David and then another one for Megan. So it's a great career to be in, both geomatics surveying and GIS. So I hope this has been useful to you guys. I have, I'm gonna have some literature here. Take it. And some business cards also. Anything
Any more
else
questions?
that I missed?
No, you're good. Any more questions?
Yes, so with the, like with the White House example,
Uh-huh.
where you had to do, interior liner, how do you manage control points? How do you get that to line up with the?
That's a great question. With the wearable scanners, what we do is we put targets on the walls, okay? And in this case, we put targets inside the wall, but outside the walls, okay? So the wearable scanner was able to register using those outside reference points, and we shot the same control with the static scanner as well. So that's how we were able, match it together. Does that make sense? Yeah, and yeah, the SLAM technology is pretty impressive, but really there is no substitution for having solid ground control. And I say ground control because these are on the wall, but they serve the same purpose. A lot of the newer technology, a lot of the UAV and a lot of the drone companies, say out there, this is really good. You don't have to use that ground control points and all that. We don't subscribe to that. In reality, doing ground control points is really not that expensive. And it's just an added insurance. If I don't use any control points, well, the drone company may tell me that I'm good, but how do I know that? I simply don't. So we hardly ever do anything with that. If we're using different technologies, we make sure that different sensors are able to see the same.
All right, no more questions? Well, thank you very much.
I have
Very much. Oh, yeah.
I have to answer you. You guys don't like us. Yes.
So, okay, so when you had when you have the multi-beam nodes,
Uh-huh.
and they're scanning for stuff, how